you can leave the job running, accruing results while you look at preliminary stuff, right?
That's true.
Okay.
So yeah, I guess so for the people who have gotten the hyperparameter search started and have gotten to the point where you've been able to run this Balsam LS, and if you see that you have jobs that are running, the next step then would be you can get started and try to log into the Jupyter Hub. So I've already done the login, but there's a link here on this README page that should direct you right there. And then you can log in with the same credentials you use to get onto Theta. So your ALCF username and then the one-time password as you would normally. And that should hopefully go pretty smoothly. Then I guess so for anybody who's gotten to that part, if you want to keep going, and I'll wait before I actually get into the, start going through the analysis to give people a chance. But for anybody who's gotten this far, I suppose, the next thing that you would want to do is navigate to wherever you have cloned the SDL workshop or wherever you ran the hyperparameter search from, which I would imagine would be inside the SDL workshop folder.
It might be helpful to just mention that when you log into the Jupyter server, you're going to be presented with your home directory's files and folders.
Yes, so yeah, this will give you, when you log into the Jupyter instance, it will display whatever in your home directory, which I would imagine is probably where people copied the SDL or cloned the SDL workshop to. And so mine is in here. So I've actually got it pulled up already in this other window here, but yeah, you should, opening the Jupyter Hub instance will get you to a list of files in your home directory. From there, hopefully you can navigate to wherever you clone the SDL workshop and then navigate to the hyperparameter folder, hyperparameter search folder. And it's hard trying to make sure that everybody's keeping up in Slack. And then once you've got all of that set up and you have the Balsam jobs running, you can use this BCD command to jump directly into the directory where you've got the search running. So I should have so if you've gotten the job running, you should be able to navigate into the directory where the results are being put to, and where Misha was showing the results.csv and the tail, he was looking at the output from the DeepHyper search. So yeah, it looks like people running. Yeah, so I see in the Slack now, there's a lot of different things that could be done. And this was meant to be a pretty trivial example just to kind of get you familiar with how things work. And obviously there are a lot of things that you can do to improve on this. So yeah, I think like Kyle suggested trying this on your own time. If you have free time at the end of this tutorial, maybe try modifying the model run.py file to change the network structure. You could add convolutional layers, things like that, that would definitely improve the model's ultimate performance. But for the sake of making sure everybody's familiar and things run smoothly and quickly, we just went with a somewhat simple model. And so once you've gotten the Balsam job submitted and everything should be running smoothly, hopefully you've then been able to log in to Jupyter Hub and get to the directory containing the results. And once you're in that directory that has this results.csv file, you should be good to go. The example I'll be working through will use the results.csv just from the GitHub repo. So this is just a copy of the results file at the end of a hyperparameter search that was moved into this directory just for simplicity. Yours will be located somewhere else, but just to give you guys an understanding in how this works. Ideally, you would wait until your hyperparameter search is completed, and then you would have this results.csv file in its entirety that would contain the results from each of the model evaluations. So once you've been done with that, you can then run this DeepHyper analytics command, and providing this -p flag would then takes in as an argument the location of the results.csv file. So if you're already in the directory where that exists, then you can just pass it like that. And that will basically run a step of analytics computations to generate, or on that results.csv file, and will automatically generate this DeepHyper analytics hyperparameter search notebook. So you should also be able to do that even if your job is still running. You can run this DeepHyper analytics command on the results.csv file, and it'll automatically generate that analysis notebook. Do you need to load a Jupyter module from the theta login? So you don't need to load a Jupyter module from theta login. If you are on the README in the GitHub, just run in case of 4 nodes are not to results.csv. So the results.csv file won't be automatically generated. Once you're in the directory, I did not see results.csv. So if you're not seeing a results.csv file, it could be the case that your job hasn't started yet. Yeah, so if the tasks haven't finished yet, then this results.csv file won't have generated yet. So it's hard to say how long I should wait to make sure everybody has a chance to catch up versus going through this. Let's see. Okay, so it looks like if whoever had just submitted this, it looks like you've gotten some jobs finished, so you should have a results.csv file.
Well, I think it's me submitted. I initially submitted with 2 nodes, and someone says this is too slow. So I just submitted another one, put it in another folder. And when I use a queue status to look at it, looks like results. Like I didn't see the job with a 4 node.
Yes. Thanks, Misha, for helping out with that.
When you ran the DeepHyper Balsam submit, did you get a success message? Because DeepHyper won't let you submit 2 jobs with the same experiment name. So it may be that you need to, if you called the first one MNIST demo, you should call the second one like MNIST demo 2.
Yeah, I call it MS demo underscore N4.
Oh, I see that actually in your screenshot. Yeah.
Right.
So it looks like that's actually, no, that's also running. So yeah, you can jump into the working directory of a job. So if you do that bcd command, okay. And yes, results.csv is getting appended to. So even while your job is running, you'll see results.csv, and it should keep growing.
Yeah, so that's a good point. So what Kyle said on this, that the DeepHyper analytics command only needs to be run once this result.csv has been initially created. And once you've done this DeepHyper analytics, that should automatically generate this Jupyter notebook file containing the commands that you'll need to run to generate plots and things like that. So this.
We should clarify that the results.csv is down in the working directory of the job or the problem that you created, right?
That's right.
Yeah, so that's right.
And there is a results.csv file in the repo when you check it out, but
Yes.
you can analyze that probably, I assume.
Yeah,
But,
that was the original plan, was that I was just going to go through the Jupyter notebook using the pre-populated results.csv so that everybody can see how it works. But now that we're giving people a chance to it.
Yeah, I would show people how to navigate to their working directory, use that results.csv, and be aware that that results.csv file is
different.
Will be continually updated.
Oh, okay,
so
right.
It's not. Don't worry that it's there, and your job is still running, because there are some people who are wondering why it's there already while the job is running. It's
so
updated.
That'll just be continuously updated while
That's right.
Updated with new data as it comes in. But so I'll kind of go for people who might be a little confused yet. So I'm currently in the directory, the SDL AI workshop. So I cloned it into some directory, and now I'm in this, make it a little bigger so people can see, the 01 basic hyperparameter search directory. And I've gone through the same steps that Misha did earlier of initializing the Balsam database and then connecting to it. And so if you have been following along in that first section, you would have ran some DeepHyper some DeepHyper Balsam submit command that looks similar to this. And you named the database demo or MNIST demo, whatever you ultimately named it. And then once you ran the Balsam init and source the, yes, exactly. So that's an important point what Misha said. There are two different results.csv files. Once you've gotten your Balsam jobs running, you should have, if you run Balsam ls, should give you a list of all of the jobs that have been submitted and ran. And those will be located in the directory, whatever you named the database. So in this case, it's just DB. So I can go into that database directory and see what's in there. And where the results.csv file of your job will be created will be in this database data directory. And in my case, I call it momentum. And then there will be one kind of master directory that is the name that contains the name of your workflow, and then a bunch of separate directories, each from the separate task evaluations of the model. And so you are going to want to go into the momentum well, in my case, it's momentum, whatever you ended up naming it. And then if you go into there, you'll see the output from the DeepHyper, or the output from the run, the DeepHyper log file, and the results.csv file, which is most important. So I think from the Slack, it seems like people are getting maybe a little bit more familiar. Hopefully things are working a little better. But once you've gotten into this directory that contains the results.csv, you should be able to then run this DeepHyper analytics command. And running this DeepHyper analytics command on the results.csv will run. And that should have generated this DeepHyper analytics notebook. So then from your Jupyter Hub, you should be able to go in and find that IPython notebook, or that Jupyter notebook. So in my case, I go into the database directory and then into the data directory and keep going till you're in the same directory that you ran the DeepHyper analytics command from with your results.csv. And that should have automatically generated this IPython notebook, which I can see is here. So if I open that notebook, it should already be pre-populated with information that it'll need to run the analytics. So this first cell is important in the sense that it contains the path to the results.csv file that we want to analyze. But this can be any results.csv file that's came out. If you run the DeepHyper analytics command on a particular one, it'll automatically populate this. But you're free to change this if you have a different results that you want to analyze without having to rerun the DeepHyper analytics command. That just specifies the path to that data file. Then you can run all of your imports, import matplotlib, things like that for plotting. And this next cell will basically set up some matplotlib parameters for plotting, and then import the CSV contained in the path to data file from above and read it into a pandas data frame. And we can then get tabular result of the first so many results from that results.csv, and it just kind of prints them in a nice, easy to read format. We can then run this describe function on the data frame to give you some ideas about some statistics about each of the runs and how different hyperparameters change that. So this just contains statistics about each of the different hyperparameters, what values were ran, what the average batch size was that we looked at, which can be useful if you want to get a little bit more information about what the actual search did. So I'm just trying to follow along, see if there are anybody else is asking me any questions specifically. Not that I see though. So if you're still following along with the Jupyter notebook, can continue to go through. Okay, it looks like somebody got something resolved. That's good. Continue going through each of these cells line by line. So the next plot, this search trajectory cell will basically plot the trajectory of the objective versus time. So you can see how it changed with time. This isn't a particularly good or thorough search. You can see it only has so many points and didn't ultimately perform very well. The example in the GitHub repo is a little bit better in terms of statistics, but for being interactive, the actual results of the hyperparameter search aren't terribly important. It's more important that you're familiar with everything and are able to get it up and running. And so ideally this would, if we look at the one in the GitHub repo, we can see that it ends up doing a lot better. So by the end of it, it has some objective that's more or less maximized, and between different evaluations, it remains more or less consistent and seems to have converged to about whatever value it's going to ultimately get to, especially with it being such a simple model. There's not a whole lot of different sets of hyperparameters that would give poor results. But yeah, you can show this might be a little bit of a better example that's in the GitHub repo, but just so everybody can follow along, these are the results from a particular hyperparameter search. And so the next thing we can do is look at the kind of correlations between different hyperparameter values. Should hopefully plot. And so this is a pair plot showing each of the different hyperparameters and how they are related to one another. So since this hyperparameter search wasn't particularly good, the data isn't great, but one easy thing that you can see is that so if we look at this bottom row, this vertical axis contains the objective that we're looking to maximize, and we can look at how that varies for each of the different hyperparameters. So an objective closer to 1 is better, since the objective we're looking at is accuracy. So all these points at the top would ultimately be the points that did the best. And we can see how that varies for each of the different hyperparameters. So as the batch size goes from 0 to 500, we get this kind of distribution of objective results. And similarly, you can do this for each of the different hyperparameters. So how the objective varies versus the dropout in the first hidden layer. And we can see that it seems to do maybe a little bit better for smaller values of dropout, since there's this little cluster up here. Maybe a little bit similar result for the dropout in the second hidden layer, where you have this small cluster of points up in the upper left corner. And similarly for the learning rate, so obviously a very large learning rate won't perform very well, and which is again why you have this sort of cluster in the upper left corner. And then you can kind of continue with that along that train of logic for the rest of the hyperparameters. So units also seems to do best when there's a smaller number of units in the first hidden layer and then a larger number of units in the second hidden layer. So it seems that the objective is larger for number of units being closer to 50. And then kind of just a bunch of different results for the momentum, which again is only implemented when we're using the stochastic gradient descent optimizer. But yeah, this is a pretty informative plot that lets you look at how different, lets you look at the relationship between different hyperparameters and ultimately their effect on the objective. And then finally, you can generate this heat map for each of the different hyperparameters and see the correlations between different hyperparameters as well, which is just kind of another illustrative way of looking at the results from your hyperparameter search. And then finally, if we were to have ran this search on a real model or a problem that we cared about and let it run to the point where we could be sure that it had confirmed to or converged to what we would expect or would be the best objective, we can automatically just pull that out from the results.csv file and look at the hyperparameters that gave the best objective. So in this case, it's the scaled exponential linear unit as the activation function, batch size 268. And again, so these results this isn't necessarily the best set of hyperparameters you could use for this MNIST problem, since we didn't let the hyperparameter search run for very long. And if we were to have let this run for longer and had maybe constructed the model a little bit better in the first place, we would have gotten a different set of hyperparameters. So this is by no means the actual set of hyperparameters that best trains the model, but for the amount of time that we looked at and the situation and the simplicity of the model, this is the result. And then you can also print it out as a dictionary, and then you can use that then when you are actually going to train your real model that you're interested in. So this was an example showing the results and how you would actually go from running the DeepHyper analytics command on the results from your DeepHyper hyperparameter search. If you're actually looking to get a little bit more insight into the results of this, it might be useful to look through the results that are in the GitHub README, since this was a little bit more involved hyperparameter search and has some more data points. And you can see obviously things ran for a lot longer, so you end up getting a lot more points in the pair plot. So this is probably a little bit more informative plot and contains more points, so you can at least get a better understanding of the distribution. But if we look at this, actually, we can see that the majority of the results seem to have done pretty well on the objective. So for across all of these different hyperparameters, the bulk of the data for the objective ends up being clustered around 1, probably not 0.9 something, which would be the accuracy. And so ends up being a little bit better results since it converged a little bit nicer. And following the same train of logic, you can then look at the set of hyperparameters that gave you the best objective. And then if this were a real example, you could then use those hyperparameters for training your model, which would then hopefully give you better results and would benefit you as opposed to doing things by hand, which I think can be tedious and isn't very, there's not a set of instructions that you can follow just by hand that would automatically lead you to this result. So it's very easy to, and I'm guilty of doing it in my own work as well, where you just change things by hand and you try to change some hyperparameter that you think might do better. And then that ends up being a very iterative process that doesn't have any asymptotic guarantees about giving you the best model. So wherever possible, I would recommend to try running a hyperparameter search, and that is generally preferred to manual tuning of hyperparameters. It can also be kind of surprising. So there are some instances where the hyperparameters that best optimize your model are not the hyperparameters that you would have expected. So this becomes even more important when you're looking at the neural architecture search problem, where you also are considering a bunch of different neural network architectures. And I think with the fine tuning of machine learning being more of an art really than a science, I think there's a lot of room for automation, and I think getting the user out of the way as much as possible ultimately ends up benefiting the results you obtain, things like that. So I'm trying to follow a little bit in the Slack channel, and it looks like people have gotten it have been pretty good about responding. So also, obviously, feel free to interrupt me at any point I'm kind of just up here blabbing at this point. So if anybody has any questions about anything, or if there are any questions about DeepHyper in general, about this specific workflow, feel free to ask away. It would be easier if you're trying to get my attention directly to unmute yourself, since I actually don't think I've looked at the Zoom chat at all. So I've not seen anything that would be in, yeah, go ahead.
Yeah, I have a quick question. So like in general, so I know, so we just did like the HPS example. So like in general, would you kind of like do HPS and then like NAS for optimizing a network, or is it like vice versa? Or like, how does that work?
It's actually usually the other way around. NAS is still very much in the domain of research and where folks are using it. It's very successful, but it's a newer field, I would say. But typically with NAS, you're not just tuning a few knobs in an existing model. You're actually searching the completely different network architectures. And the only way to really do that efficiently is to train all of these architectures with either a small amount of data or for a shorter number of passes over the data. So like limiting the epochs. And then when you identify like the most promising candidates from NAS, and then you say, okay, these look like they might be good. Then you train them further. And then you could say, all right, now let's start tuning learning rate and so on. So you might iteratively do some NAS and then further to refinement with HPS.
Okay, yeah, I see. That makes sense.
NAS, you could say, gives you the parameters, and then HPS gives you the hyperparameters.
Oh, okay. Yeah, thank you.
Yeah. Yeah, so it looks like we still got, what time? A half hour or so till we break for lunch. So this is really time then for you guys to ask questions, or if anybody's ran into any problems with this. Hopefully, the idea was that by doing everything only on the theta nodes, this would hopefully cut down on some of the problems people were having on trying to get everything to work with theta GPU, theta KNL, and hopefully resolve some of the confusion around where things are supposed to be ran and how to get into different systems. So I know, I remember even when I first started, and remember when I was an attendee at this 2 years ago, actually, for the first time, 3 years ago. It's very easy to be overwhelmed by the different systems and how to get into where and where things should be ran from. So I think hopefully a lot of that should have gotten sorted out yesterday, but.
Maybe we should say something about the default exploration versus exploitation parameters in the search. Romit, maybe if you're here, you could jump in.
Yeah, that would be.
Sure. So I am not quite familiar with what the lambda is right now. Let me see if I can quickly take a look at the docs.
So I think it defaults to 1.96, or at least that's what I was seeing in my logs. So they're calling it kappa in the DeepHyper log.
Sure.
Right? If you search deephyper.log, yeah.
Mm-hmm. So you could, for example, change that value to something that's smaller if you want to exploit more. If you want to explore more, then you can make that value bigger. So 1.96 is basically classical statistics for the confidence intervals around the mean, correct? So so I think that's why 1.96 is a good choice for that. I personally have always just left it at the default because of that reason. You know, if you assume that the samples are being drawn from a Gaussian condition on the inputs, then 1.96 implies the confidence interval around the mean. So you can use that to explore as well as exploit.
So you can set both 0 and infinity there. So 0 in the 0 limit, you're just exploiting,
right?
And then you would be very much dependent on the initial seed. Like you would be, if you got unlucky with your initial set of evaluations, you would converge to some local optimum, which when there could be a much better solution, but it would be much faster to converge. And if you set infinity, you'll never converge. It'll be searching without any regards to the actual value of the mean.
So I think in this context, you usually want an infinity, right? I mean, we're just searching for hyperparameters. There's no real, why would we want to exploit at this point? Is that accurate?
Well, I guess it depends on your budget and your goal. So if you want to get to the best possible model in a reasonably short amount of time, I think it makes sense to do a little bit of a scatter and then try to converge quickly. So that I think the default value tries to balance those, but it's hard to say. And I think obviously the amount of time that you spend exploring will probably, I mean, my intuition is that it would go up a lot with the dimensionality of the space, right? So if you have just a couple of hyperparameters, you converge more quickly.
There's also a good question. Oh, go ahead, Taylor.
How many min and max areas you have, right? If you have a space where there are quite a few local min or max, depending on how you're optimizing, of course, you want to make sure that it searches well enough to find the biggest well and not the first one that it finds. Misha, can you quickly instruct people how to resubmit the same task for another batch job on Theta so that they can continue their search?
Sure.
And also whether or not you can do that with a different number of nodes. That was the specific question, and what constraints you have on how you can modify your allocation.
Yeah, let me put that into Slack.
Also, can any attendee confirm that they've been able to use the Jupyter Hub? Someone's saying that they can't log in. I just kind of assumed that your ALCF credentials would work, but
yes, it is working for me.
Okay, good.
Okay, good. Yeah, I kind of had assumed that people running into problems would have spoken up, but yeah, it's also definitely the case where people just run into problems and don't say anything, and then you never have any idea. So good. I'm glad to hear and see that it seems like some people have been able to get in and run it successfully. I'm guessing anybody who hasn't spoken up was also able to do it. Oh, sorry. Was also able to do it successfully. Also, thank you to whoever told me privately in the Zoom group chat that you couldn't hear me. I didn't see it until just now, so it wasn't very useful, but I appreciate you trying. Yeah, so hopefully this went somewhat smoothly.
Also, if anyone has gotten the chance to try a different value of kappa, it'd be interesting if you could share your plot, the search over time, the objective over time in the chat. That'd be interesting. And also, if anyone managed to implement the earlier convolutional network and do a search on that, please share it in the chat.
There were was a good suggestion from Venkat that we should have everybody turn on their video cameras and do some like conference attendance video screenshots.
Oh, okay.
You know,
It's
like
different not being able to get the whole group picture like normal,
So
right?
it's a group photo.
yeah.
Normally we have the nice photographer come in. Everybody gets in a big group.
Right. That's right. I don't know if you want to do that like right now or maybe 10 minutes before lunch or something. I don't know. Oh, we're gonna get Kyle's dog as well, of course.
I
The
think
puppy.
just before we break for lunch. I don't know.
Well, people are starting to turn them on, so maybe we should just go ahead.
Let's just do it now.
I suppose.
Okay.
So I mean, I don't have a problem, but I'm not sure how to stop sharing my screen. I can leave it open if people are still
Well, I
interested,
think I could solve that problem for you.
Oh, that would also work. Yeah, I'm a lot more familiar with Blue Jeans than Zoom.
There's
so
a
this was
button
kind of...
at the top of your screen.
Oh, yeah, this hovering, floating thing, the stop share. Got it.
There
we go.
So the equivalent of the guy going on the stairs and saying like moving people around is someone with a...
Yeah.
I like somebody said they need to change what they're wearing.
Okay, let me see.
That's me.
I've got one screen full of people. Kathy, India.
Everybody, screen or camera on, please. Pets are welcome.
No, the pet shot comes after this one.
Yeah, Kyle has an NDA approved attendee.
And let me see. 3 screenshot. I got the first screen of people. There's a lot of people on screen too that don't have their cameras on. You're allowed to use sock puppets too.
You don't want to.
If you're attending in your pajamas, you can use the sock puppet.
I can't tell if that would be more or less embarrassing than just whatever you would be hiding.
Well, it depends on the quality of the sock puppet.
That's true. That's very true, I suppose. If you had one pre-made for this occasion, it would be a good time to use it, I suppose.
Well, I think if we want everybody, we may need to try again some other time. We really only got about a third of the people.
Okay. The thing is that you can mix and match. Every day you take a new picture and then you just cut it. And
yeah, we could do some Photoshop magic. Yes.
Yeah, if you don't turn your video on, we're gonna find a nice Muppet to stand in. We're slowly getting more people with their video.
Oh, are they coming on? Hold on, let me. Page 2 is looking a little better.
Okay. Well, thank you, everyone. And we will continue the DeepHyper work. I feel like jobs had fallen off on Theta. Feel free to edit the model. I know there was some discussion about the fact that we have a simplified model. You could, of course, if you feel confident, you can replace the dense layer 1 and 2 with some convolutions. Feel free to add a third dense layer or expand the search space. It's good to dig into those details and work with DeepHyper while we're here so you can ask those questions. That was the goal of, not filling the entire time with us yammering at you.
Yeah.
And so we are online. In 20 minutes, we'll break for lunch, but feel free to eat lunch and continue your parameter scans. you could drag and drop one of the, the run function that Misha put in there is based on a simplified model, but you could easily just cut and paste one of the models from yesterday's examples into the code. You'll need to play with the point dictionary a little bit, but
yeah, it should all be pretty, I think, hopefully straightforward to use and change. So that was kind of another one of the design choices, I guess you could say, about this, was that we wanted to provide somewhat of the simplest, a relatively simple example that is able to show some improvement as the hyperparameter search goes on. But the idea is that you can really, exactly like Taylor said, just drag and drop your own model implementation, in which case you'd have to update the hyperparameters as well. But then again, that only really amounts to changing the entries in that dictionary or in the problem file. So, and this is really the goal of all of this at the end of the day, is to get you familiar with the tools that we have and how you can use them for your specific science applications. So obviously in your real work, you're not going to be just training the MNIST model to classify the MNIST digits. And you obviously want to do whatever it is that you're interested in, the reason why you're attending. And so you can hopefully, using the tools from this tutorial, you should then be able to completely swap everything out that we've put in there with your model and your objective that you want to optimize, and hopefully we try to make everything be as interchangeable and as accessible as possible. And so I also would like, to recognize everybody who works on this DeepHyper project and Balsam. It's really a very useful and simple tool that is very effective and very good at getting you the results that you want, and easy to understand. There's a lot of documentation online, and so I think that it's a very useful tool, and you should definitely take advantage of it if your personal use case could benefit from it. So like Kyle said, if you get not a number for the momentum, that should be fine. That's to be expected if the optimizer you're using is not the SGD. Awesome. Failed. But so I guess one other thing, if we have time, since looks like some people are still getting problems worked out. I know Misha talked about it in the previous part, but one thing that we did or tried to do, was provide you with, I forgot I'm not sharing my screen now. The ability to introduce this conditional parameter, so the momentum only being included in the hyperparameter search when you're using the stochastic gradient descent optimizer. And that is one simple way that you can make your search space a little bit more complicated. So you can imagine building on that and expanding it even further. You could have additional condition statements that would only include certain hyperparameters in certain cases and things like that. So you can very easily generalize this simple modification to construct search spaces that are somewhat arbitrarily complex and tailored specifically to your model.
there was, I wanted to show quickly a plot of the, you had shown the pair plot earlier. And as
yeah, right. Wasn't particularly good, but
yeah, I just wanted to show an example of
yes,
what happens when you really run for a while. So here's an example of a pair plot that has lots of points in it, and you can see performance behavior. So this is the objective that I was using to optimize at the time. And you can see in your distributions where, I'm looking for peak, a maximum in the objective. So you can see for the features I cared about, there was definitely strong, leaning in certain parameters, whereas other parameters were less important in achieving the peak objective, whereas others have a very linear behavior here. So that's where the pair plots come in handy, is they can show you. And I was also, in my pair plot, I was dividing based on the objective that had high value objectives and low value, and then I colored them based on that, so that in some of the cross plots, I could see how the peaks were distributed around in the other variables. So anyway, just something to, those plots are helpful after you run for a while and sample your space.
It's a weird error message I'm seeing in the Slack. URL fetch failure on.
That could just be, so it's grabbing the MNIST data set. So that could be a network pipe timeout or something.
Yeah.
So on these big HPC systems where when you have a lot of people trying to do things like that, the outgoing pipe on theta to the rest of the world is definitely under power, compared to the number of potential nodes that could be reaching out to the outside world at any given time. So it's not uncommon to see that the network can't handle 10,000 requests in parallel.
Oh, yeah, that makes sense. It looks like the data wasn't downloaded before they tried submitting the Balsam job, and so it wasn't able to pull it on the compute node.
Nice, I see somebody submitted a 128 node job.
So I guess we could also, if there are any questions, also feel free if there were any like questions from yesterday, if anybody was never ultimately able to get the distributed examples worked out. Yeah, feel free to bring up any problems that you are outstanding that you're still having, or general questions. It's a lot easier to get answers from us about simple questions like that and stuff now than it would be. Not that it's impossible later, but it's, you know, if you had to send an email or something, it's a lot less real time. So it's useful to ask the questions while we're still here.
People should feel free to run with more nodes. We've got 256 nodes reserved on Theta for today. You know, obviously, if you grab a big chunk of them and you notice other people's jobs are then queuing instead of running, I would ask that you stop. But you know, feel free to use 10, 20 nodes, as long as not too many people take me up on that. But at the moment, we only have we've got 30 nodes being utilized out of the 256. So you'll get more sample points and get a better feeling for what your phase space is looking like.
Yeah, so I see someone asked if we're still able to run and submit jobs from the things. Oh, outside of the reserve time on Theta. I see the question. So yeah, we have the reservation from 9 a.m. to 5 p.m. But yeah, I see what you mean outside of the reserve time. So I actually am not sure about how that works. You'd have, like, if on the account creation, I think you would need to, if you wanted to ultimately get more time, you would need to apply for an allocation, which I think somebody said there will be a session on tomorrow, right? On allocations.
Yes, that's right.
Okay. Yeah. So yeah, that'll be explained in more detail tomorrow for people who are confused. But yeah, so you can apply and I guess see what happens.
I think it will be covered tomorrow. In brief, we have the director's discretionary allocation, which will help you get going and prepare for larger scale allocations. And we have several other allocations. The primary one is the DOE Insight. We have the ALCC allocation, as well as the ALCF Argonne Data Science Program allocation. And we'll provide you with more information tomorrow, and we can also point you to relevant links on Slack as well.
So maybe one other thing maybe that might be helpful to people. If you have made any changes to your default, like the login environment. So if you are using bash shell and you've modified your bash RC, or if you, I think it gives you the option when you create an account to use Z shell as well. And so if you, which isn't officially supported at the moment, so you're prone to running a little bit some errors if you used Z shell or if you selected Z shell. I think it's in the process of going forward. I think that's something that people have expressed an interest in having better supported. But if you selected the default as bash shell and if you've made modifications to your bash RC, it's very possible that you could break things. So I've personally had this happen many times, and it can be a pretty big headache trying to figure out what settings you're overriding that ultimately make things not work. And so I actually recently found out that you can you can request basically a clean default environment on login. So let me see if I can remember what the command is. So you can, when you're trying to log in, you can, this is in the general channel, I suppose. And that will get you a clean environment using bash shell and hopefully resolve any environment problems that you've created. I don't know if that's, I don't know how useful that is, but I know personally, I always tried to navigate things using Z shell and configured things that ultimately broke things that shouldn't have been touched. And a very easy way to get around that is just use default settings when you log in. And then everything should always work smoothly, hopefully. So, sorry, somebody said, so definitely no stupid questions. Feel free to ask anything that any problems you run into. I'm sure other people, if it's something that you're experiencing, then there's a good chance somebody else is as well. And so somebody actually speaking up on it will hopefully then benefit other people. So what's the next step after setting the path to the data file? So could you be a little more specific, which data file? So try and get it resolved. Yeah, so yeah, you could, yeah, sorry.
No problem. So we'll continue to field questions via Slack and whatnot, but I'm going to go ahead and call lunch. You know, I see people are utilizing the reservation. That's great. See some bigger jobs flowing through. And we will be, we'll break for lunch, come back at 1 Central for our profiling deep learning session with me, Huiho, and Murali. And please continue to use the Slack for discussion and questions. And I'm sure people will still be here. Make sure you stay connected to Zoom, just so it's easier when people come back. And maybe if maybe 10 minutes before 1, if people are here, you could maybe a few users, if they want to share their pair plots to show how far their parameter search got. You could do something like that. Otherwise, we'll see you in a little bit. I'm going to mute and go grab a bite to eat.